Let's say you're traveling at a constant 50 miles per hour. The graph of your speed would look like a horizontal line. It's not changing. Since this is your speed, it represents f prime, or the derivative of your position. What would the graph of your position look like? If we start at position 0, after 1 hour, you'd be 50 miles away, and after 2 hours, you're 100 miles away. This is just a line with positive slope. In fact, the slope is 50, which should make sense. Notice the graph is increasing or going up. That's because the slope is positive, or the derivative was positive. What if we were driving backwards, so our speed was minus 50 miles per hour? Now, instead of increasing, position is decreasing. It's a line with negative slope. Remember, if the derivative is positive, the original function is increasing. And if the derivative is negative, the original function is decreasing. Let's do an example. I drew 3 axes because I'm going to draw 3 graphs. F, f prime, and f double prime. The first graph I'm going to draw is f prime, and we'll use this to draw the other 2. Let's draw f first. Remember, if the derivative is positive, the original function is increasing, and if the derivative is negative, the original function is decreasing. So we want to find where the derivative is positive and negative. I'm going to draw vertical lines to mark where the derivative is 0, and in each region I'll put a plus or minus. Transfer these vertical lines to f, and replace the plus or minus with arrows to indicate increasing or decreasing. Make sure your arrows are slanted up to the right or down to the left. It will make drawing the graph much easier. Now draw a curve that matches the direction of each arrow. Don't just draw straight lines, make it curvy. I want to point out a couple of things about this graph. Look at these points. They are the max and mins of f, and they correspond to where the derivative is 0. In the future, this becomes basically all we do in this course. Find the derivative, set it equal to 0, and find the max and mins of the function. That's f. Let's draw f double prime. I want to do everything I just did again, except in reverse. Think of f prime as our original function and f double prime as the derivative. I'll mark the max and mins of f prime with vertical lines and indicate if f prime is increasing or decreasing. Transfer the lines to f double prime and mark each region as positive or negative. Finally, draw a curve that matches. A common misconception is thinking that it's wrong that f double prime is supposed to be positive here, but look, it's decreasing. The positive just means where the function is in relation to the x-axis. The positive means above the x-axis, which this is. We can see that where f double prime is 0, f prime has a max or min. But what is f doing at those points? I'm going to emphasize with vertical lines. On each side of these lines, the function is cupped in a different direction, either up or down. This is called concavity, concave up and concave down. Where concavity flips is called an inflection point. Remember, if the second derivative is positive, the original function is concave up. And if the second derivative is negative, the original function is concave down. This is a lot of information. Let's write it down to keep ourselves organized. If f prime is greater than 0, then f is increasing. If f prime is less than 0, f is decreasing. If f double prime is greater than 0, f is concave up. And if f double prime is less than 0, then f is concave down. I remember the concavity because if you're positive, then you're happy. And if you're negative, you're sad. Here's a table to help keep you organized. Each cell is a possibility of what the graph looks like. You should really pause the video and determine the shape in each region. For example, in this cell, the function looks like it's increasing and concave up. Well, I'm sick of waiting. The table looks like this. I don't expect you to memorize this, but you should understand it. One last example. Draw a function f of x where the following are true. You'll need an axis. I typically resolve first derivatives first. Look at the cutoffs, -3 and 0. Draw 2 vertical lines. In each region, we're going to draw an arrow. Where the derivative is positive, I draw an increasing arrow, and where it's negative, a decreasing arrow. Next, I'll do the same with the second derivative and concavity. It's a good habit to put increasing, decreasing on top of the graph and concavity on the bottom. It just helps keep you organized. With all this information, we can draw a graph. This is, admittedly, a skill that takes some practice. My graph looks like this. Here's what you need to look out for. Make sure your max and mins are in the correct places. Just look at the arrows on the top of your graph. Make sure your inflection points are roughly correct. This can be a little tricky. And finally, make sure you don't start decreasing when you aren't supposed to. Sometimes people will hook down like this, but that can't be correct since the arrow is pointing up, so the graph should be going up.